So we are going to understand next the pressure due to liquid, how liquid exerts pressure. Write down the heading, pressure due to liquids. Okay, see, when you talk about the three different states of matter, solid, liquid and gas, the gaseous particle exerts pressure due to collision, and that we have already discussed. When the two gaseous particles are moving, they collide, and the force per unit area that we have there is called the pressure, right? So the gaseous particles exerts pressure because of collision, they collide, correct? If you talk about solid, the solid particles exerts pressure due to its mass. Table here, right? Suppose you have a table here, and on this table, if you place a block of certain mass like this, okay, this is suppose 5 kgs, if it's 2 kg mass we have here. So the weight component of this mass of 5 plus 2, 7 kg here, that is mg. This force that is acting on the block, like in downward direction, which is there on the table, right? So this force per unit area on this table is the pressure on the table by the block, that is 5 plus 2, 7 kg block, right? So this exerts pressure because of its mass, correct? We can also add some block over here, the pressure will be more because it has more mass. So solid exerts pressure due to its mass. When you talk about liquids, it exerts pressure due to its height or depth, also we can say, whatever, depth. Okay, have you seen this formula? I want you to respond, all of you. Have you seen this formula before? P is equals to H rho G. I'll write down this for just a second. P is equals to rho GH. Have you seen this formula? Correct. What is this rho GH means? Rho is the density of the liquid, H is the height, and G is the gravitational pull. How do we get this formula? You know that? The derivation of it? Okay, fine. Quickly we'll go through it. See what happens as the height of the liquid increases. Suppose you are at this position and this side you have liquids, correct? So at this point, you'll have certain pressure because of this column. It's not the water that is below you. We have nothing to do with this. The water which is above you, whatever the height of this water column we have, this height will exert pressure, correct? So here we'll have more height, right? Then the pressure will be more. If you go up, the pressure will decrease. Go up, the pressure will decrease. The pressure will decrease, correct? So as you go deeper into the sea, the height of the water column above you increases, and hence pressure also increases, right? That's why you see when you go, deeper, like 50, 60 feet, if you go, randomly I'm taking some number, right? Not very sure with it. But after a certain depth, the divers, they start bleeding from the nose because the pressure is continuously increasing. on his body, right? That's why it becomes very difficult to go beyond a certain point into the sea or river or whatever it is, because gradually the height of the liquid column is increasing, and hence the pressure on you is also increasing. That's why it becomes difficult. Okay, so liquid column exerts height because of its pressure. Okay, so based on this formula, we are going to use this formula only. How do we get this formula? Quickly we'll see this, and what kind of problems we are going to get that we'll discuss. Correct? So now you see. So we are going to discuss a device, that is barometer, which we use to measure pressure. Write down into this. Write down. It is an instrument which is used to measure pressure of liquids comma in barometer the liquid which is used is mercury. The liquid which is used is mercury. Correct? Why we use mercury? Because it is non-sticky, plus it has very high density. Volume is less, so it occupies less volume, right? So why we use mercury? Because it is non-sticky, the volume is less because of its high density. Write down. Now you see this. Suppose we have an arrangement. We have a beaker like this. Correct. This is filled with mercury, for example. Okay. This is filled with mercury. Hg. And if you place a tube like this with open end downward, then what happens? This mercury column will rise in the tube and it goes to a certain height. Right? Suppose this height I am assuming h. It goes to a certain height and it depends upon the atmospheric pressure. Okay, we'll discuss why and how. But obviously when the open end you will put it down, then the mercury column will rise into the tube. And we have this arrangement here. Now, could you tell me the relation of pressure at point P, and it's the same level, and Q. This is P and Q. P and Q are at the same level. The pressure at P and Q is what? Same pressure, okay? So we can write at the same level because the depth is same, height is same. The pressure at P and Q would be equal and same, right? So because of liquid, the pressure varies only when the depth of the liquid is different. It is same for these 2 points, hence the pressure here would be same. First point. Could you tell me this point is, suppose I'm assuming A exactly at the surface of this liquid A, and here the point is B, I'm assuming. The pressure at A and B will also be same, right? Okay, yeah. What is the pressure at A? Since it is open, so P at A is nothing but the atmospheric pressure. Okay, it means it is the pressure at B also. Now this liquid column, Hg column, will rise in this tube and will go to a certain height, because we know as the height increases, its pressure increases. So height of this column, if you consider at this point, when this pressure of this column equals to the atmospheric pressure, that is the pressure at B, then it won't, you know, go further. The rise in the height will not be there once the pressure of this liquid column equals to the pressure at B. Isn't it right? Yes, correct. Understood. So can I write this? The pressure due to liquid column due to Hg column, I'll write down, in the tube equals to the pressure at B, which is nothing but the atmospheric pressure. Okay. Now you see, this part I am drawing it separately here because we need to balance it. The force we must be equal. So this, the liquid column will have here. Suppose we are assuming this is the Hg column we have. Exactly this part I have taken over here. Assume this. So obviously this will have certain mass. So its mass component is mg, downward direction, right? And this pressure will exert in upward direction, P atmospheric, that is the pressure at B, into the area of cross section. This is the force in upward direction. Right? This B will exert pressure, P atmospheric, into the area of cross section, becomes a force in upward direction, and weight component is in downward direction. No doubt in this. At equilibrium, what we can write? We can write this force in upward direction equals to the force in downward direction. Okay, m is the mass, g is the acceleration due to gravity. So P atmospheric into A, mass of the liquid obviously we can take. So density into volume. This is for Hg into G. Any doubt here? Further, what we can write, that atmospheric pressure P atm into area of cross section equals to rho density into volume would be what? Again, area into height of the liquid column. This is for the liquid, which is Hg here we have, into the gravitational acceleration. And then this A and A will get cancelled. And the atmospheric pressure is equals to, we have rho g h, where this height is the height of liquid column and this rho is the density of liquid, sorry, mercury. Anybody has any doubt in this? Clear? Now for any liquid of height h and density rho, we can give the pressure as rho g h for any liquid. It's a general thing, rho g h. Now since we know the atmospheric pressure, so we can find out the height of the mercury column. What height of the mercury column exerts pressure which is equal to the atmospheric pressure? So when you substitute all the value here, right, you will get the height of the mercury column h of hg is equals to 76 centimeter. Means if you take 76 centimeter of mercury column, it will exert a pressure of which is equals to the atmospheric pressure. That's why we say the atmospheric pressure is equals to 76 centimeter of hg or 760 mm of hg. Okay, like that. Means 76 centimeter of height of liquid Hg is 1 atmospheric pressure. Any doubt in this? Yes, all of you, you can type in CLR quickly, guys. Okay, so what we have concluded, pressure due to liquid of height h is equals to rho g h. Okay, fine. Sometimes what happens, if you look at this arrangement here, we have a column, and suppose we are having a liquid here in this beaker. Okay, and there is an again tube with open and down like this. Okay, so obviously this liquid level will rise in the tube. This is it, and we'll have some gas over here. Some gas here in this tube is trapped. Okay, this gas here is trapped. So this point is A, this point is B, right? So we have PA is equals to PB is equals to P atmospheric, right? P atmospheric. And if you write down the relation of pressure, so PB is equals to what? On this PB, on this point, this liquid will exert pressure and the gas will also exert pressure. So PB is equals to pressure of the liquid, whatever liquid we have, plus the pressure of the gas. Right? This is a relation we can write. If any gas is trapped, so if they ask you to find out the pressure of the gas in this case, right? PB is the atmospheric pressure. P liquid, you know, because the height and other things will be given, and then you can find out the pressure of the gas. The basically you need to understand that how to write down the pressure relation here. PB is here. Above it, we have liquid, so this pressure will be in downward direction. This gas will also exert pressure in downward direction, and B is in upward direction. So PB is equals to P liquid plus P gas. Did you understand this? Yeah. Now, based on this only, you see a few questions. Okay. This is open and up, open and down, and again open and up. So the question here is, we have 15 centimeter of liquid column here. Hg. 15 centimeter of Hg we have, and here some gases are trapped. Okay. You need to find out the pressure of gas. Density of mercury, rho of Hg, is 13.6 gram per ml. In this we have 10 centimeter of mercury, 10 centimeter, and here some gases are trapped. You need to again find out the pressure of gas here. Okay. Here also we have some liquid trapped. We don't know about this liquid, but the density of this liquid is given. The height is h, and the density of this liquid is given. Rho is equals to 6.8 gram per ml for this side. Here we have gas. Need to find out the pressure of the gas. Try all three. Yeah, done. Okay, so you place it in a centimeter of Hg. You don't have to place in Pascal. You also won't get such options, okay? What happened, guys? Okay, chalo, I'll do this first one. Let's see. See here what happens. We have a pressure here, this liquid column and this, and we have atmospheric pressure in downward direction. Correct. So atmospheric pressure is this PATM. What is the direction of this liquid column? Is it upward or downward? Upward or downward? Liquid column. Hello, are you there? Because of this liquid column, the pressure is in downward direction or upward direction. I have already told you, I have already told you that the height, the pressure because of liquid is the liquid which is above, right? So this liquid column, 15 centimeter of it will exert pressure in downward direction. And the pressure of gas is in upward direction, right? So if you balance this, what you can write? PATM in downward direction, pressure of Hg in downward direction equals to the pressure of gas in upward direction. Any problem in this? Tell me. Any doubt, any problem? Please go ahead. See, you just need to know the direction of the pressure here. What is the direction of gaseous pressure? What is the direction of liquid column? What is the direction of atmospheric pressure? So atmospheric pressure is always in downward direction. I am also sitting here, that atmospheric pressure on me, right? It is there in downward direction. So if you have a liquid column here, the atmosphere will also exert pressure in downward direction, right? Because it is there in upward, above only, so it will exert pressure in downward direction. So pressure of atmosphere is in downward direction. Liquid column, we know it exerts pressure because of its height. So this height we have, so it exerts pressure on this gas. See, actually what happens when this liquid column is trapped, right? Suppose liquid column will have here like this. If you can see me, this is a liquid column we have, and it will be here when this pressure and this pressure is equal. Are you getting it? Correct. Obviously, this also contributes into the downward pressure. The liquid column also contributes. But suppose when I say the liquid column is trapped here, like this, in between somewhere, like it is trapped here. So when it will be trapped? When this pressure, total downward pressure is equal to total upward pressure, right? So gas is pushing the liquid column in upward direction. Atmospheric pressure is pushing the liquid column in downward direction. Liquid column also exerting pressure on the gaseous species or the gas which is present here. So total pressure in this direction equals to the total pressure in this direction, and then only we'll have the equilibrium. Are you getting it now? Yes. Tell me guys fast. Yes or no? If you understood, fine. Otherwise, let me know. I can explain you 10 times all these things. Okay, I have no problem. But you have to, speak up. All of you understood? I'm not doing anything. I'm just balancing the force. When you balance the force, total force, yes, correct. So force, the cross sectional area will get cancelled. Shraddha, you balance the force only. The cross sectional area is same. You see in that expression all that you have calculated, the area gets cancelled, right? So you balance the force, pressure into area. This is the force because of atmosphere, right? This into A, it is a force because of the liquid column. Pressure of gas into A, it is a force because of the gaseous column. So cross sectional area will get cancelled. And hence we are left with the pressure only. Clear? Shraddha, understood this? Right? So you will get this. Now everything you know. We know the atmospheric pressure. Atmospheric pressure is 76 centimeter of Hg. We know this. And plus 15 centimeter of Hg is also present. Plus 15 centimeter. The pressure of Hg is what? Because we have only 15 centimeter of Hg. So we have 76 centimeter upward plus 15 centimeter this. So total pressure is this equals to the pressure of gas. So pressure of gas equals to 91 centimeter of Hg. Tell me, is it clear? Yes. Now, one more thing you try to understand very carefully. Okay. See, I have just added this PATM and PHG 76 plus 15, 91. Okay. Why? Because this column is mercury, right? And we know the atmospheric pressure is 76 centimeter of mercury only. So since the atmospheric pressure is defined with respect to mercury, so whatever height of mercury column you have here, you can directly add with 76. But if you have any other liquid here, then you cannot add this. In that case, you have to think again. In that case, you have to think again that if this is the height of the liquid given, this liquid will exert some pressure. What should be the height of the mercury column which exerts the same pressure as this liquid is doing, right? So in case of another liquid, which is the case number 3, we'll discuss this how to do. But first you try this one, the second one. Yes, rho Hg in that case you need to take. Yes, Archit, fine. Which one you're talking about, Shraddha? No, no, no. See, Shraddha, it depends. You cannot add here pHg and pressure of the gas. You cannot do that because the direction. See, if this liquid and the gas, if both exerts pressure in upward direction, then you can add the two. But here the liquid column is exerting pressure in downward direction. Gaseous gas exerts pressure in upward direction. So both are in opposite direction. You cannot add pHg and p gas here. That's what I'm telling you. You have to balance the force first, then you'll get the relation of pressure. Acha, the liquid one. Yes, for that you need to find out H rho g, and then you have to find out the height of the Hg column which exerts the same pressure. Yeah, okay. Okay, fine. This one I'll see first, then I'll go to the third one. See here the liquid column exerts pressure in which direction? Downward direction, obviously. right? So P of Hg in downward direction. Pressure of gas is also in downward direction. But the atmospheric pressure is in upward direction because the atmospheric pressure will hold this liquid column here, right? So we'll write down the relation here, P atmospheric. One second. We have P atmospheric equals to P Hg plus P of gas. So P of gas equals to 76 minus 10, 66 centimeter of Hg. Okay. In the last one you see, it is given density 6.8. Obviously, this liquid height column is not mercury. So here if you look at the pressure of atmosphere is in downward, P atm. Pressure of this liquid, we don't know what liquid it is in downward, and pressure of gas, it is in upward direction. So we'll write down the pressure of gas equals to the pressure of atmospheric plus the pressure of liquid. Now this liquid column is given, its density is 6.8. So pressure of liquid is what? Is equals to rho G H. Okay. And remember one thing always, that PATM is 76 centimeter of Hg. But since this liquid is not Hg, so if you directly add this 10 cent, this whatever the height we have, if we add this here, this will be wrong because this liquid is not Hg. So we cannot add height of this liquid with the height of mercury column here. So this we are not going to do here. Now, what we need to do next then? See, we have this height of liquid. This height of liquid will exert some pressure. Which pressure is this? Okay. Now we'll find out that what should be the height of the mercury column, right? Which exerts the same pressure as this height of this liquid does. Exerts. Correct? So what we have done, we have taken this pressure of this liquid and we equate this with certain height of mercury. This is the pressure of mercury we have. So with this two relation you see, we'll find out what height of the mercury column is required so that the mercury column exerts the same pressure as this liquid column exerts. So that would be the rho of liquid into the height of liquid divided by the rho of Hg. This is what the formula we use in order to find out the height of the mercury column which exerts the same pressure as H height of this liquid exerts. Did you understand this? Any doubt in this? So first of all, we'll find out this height of mercury column and then this height will add over here. So for this formula you can memorize, it is useful for all the questions, okay? In general, you can memorize this formula. H of Hg is 6.8, the density of that liquid given, 10 centimeter height, and it is 13.6. So obviously it is coming out to be 5 centimeter of Hg. This means what? That 10 centimeter of this liquid, 10 centimeter of this liquid and 5 centimeter of Hg will exert the same pressure. Correct? So here we'll simply add 5 centimeter. So answer is 91 centimeter of Hg. Any doubt in this? Tell me. Oh yeah, 81, correct. Yeah. Okay, look at this again. and let me know if you have any doubt. Just you need to balance the pressure, total pressure in downward direction equals to the total pressure in upward direction. Balance the two, you will get the unknowns. Copy this down. Yes, done. It's given in the question. Is it not given? Oh, wait, let me check. Acha, height of the liquid I haven't given you, I guess. Acha, wait, let me check this just a second. Oh, it is not, I have not written over here. Fine, my bad, guys. This height of the liquid is given 10 centimeter. Okay, that's why I have taken this. Whatever height, you just have to substitute and find out this. My bad, okay? This height is given right down here. This h is given over here. It is 10 centimeter. Okay? Fine. Got it? Understood? Okay. Yeah. Let's see this question. Another one. You can, like this, you can have multiple liquids, like more than 2, 3, 4 liquids can be given. Like you see this question. Concept is actually same. You have this tube, and we have any three liquids we have here. We do not know L1, L2, L3, and here we have gas. Okay, this height H1 of the first liquid is given, it is 80 centimeter. H2 is given, it is 20 centimeter. H3 is given, 50 centimeter. Rho of this first liquid is, density is 3.4. Rho of this is 6.8. Rho of the third one is 27.2. Gram per ml is the unit. You need to find out the pressure of this gas. Yeah, Archit, that's correct. Yeah, this end is open. This is open end. Right, Archit, correct. No, that's not right. 461 is wrong. 156 is wrong. 226 is wrong. Yeah, Kinshuk, that's right. 130 is wrong. Yeah, Ritu, that's right. Correct, Rohan. So Rohan, Ritu, Kinshuk, Arshit, you got the right answer. You must be doing some calculation mistake. Ruchita, Vaibhav, check your calculation once. See, what we need to do again, corresponding to this height, okay, what should be the height of the mercury column which exerts the same pressure? So with that formula, we can directly find out. Okay, so for the first liquid, H of Hg should be 80 into 3.4 divided by 13.6. This is 20 centimeter, I guess. Similarly, for the second liquid, the corresponding height of the mercury column would be 6.8 density, 20 centimeter is the height divided by 13.6. This we are getting 10 centimeter of it. H of Hg for the third liquid is 50 into 27.2 divided by 13.6 equals to 100 centimeter of it. Okay, and all these liquid will exert pressure in downward direction. Means what? Instead of these three liquid, we can place Hg column of height 20 plus 10 plus 100, that is 130 centimeter. Means this height of the three liquid is equivalent to 130 centimeter of Hg. So this 130 centimeter of Hg, the pressure is in downward direction, pressure of gas is in upward, atmospheric pressure in downward direction. So what we can write? We can write P atmospheric plus P of Hg equals to P of gas. So 76 plus 130 is equals to P of gas. So pressure of gas equals to 206 centimeter of Hg. Tell me, is it clear? Pressure of gas, see, Shraddha, you tried, it's logical, you can understand. See, you have gas, correct. Here you have gas, and there is some liquid column here. So obviously this liquid column has natural tendency to come down. If you remove this gas, this liquid column will come down completely, right? So you have this liquid column, which has tendency to come down, and this gas will exert pressure in upward direction. This gas only won't let the liquid column to come down, right? Hence this gas will hold the liquid like this, so it will exert pressure in upward direction, and liquid has tendency to come down. Hence the pressure of gas is in upward direction. Now you see, all of you have got the answer. Fine, so this kind of very basic questions you will get to find out the pressure of the liquid. So I guess all of you have understood this properly, okay, how to do this kind of questions, okay. So this formula that we have done here, this formula you must remember, because in the exam, when you get the question, they won't give you simply mercury liquid over there, okay. This one. This formula you must keep in mind. Any what I have done. This is see. I have made a mistake over here. Height of Hg is this. Any liquid, if it is not mercury of a certain height, okay, corresponding to this height, what should be the height of the mercury column which exerts the same pressure? So H of Hg, rho into H of that liquid divided by rho of mercury. This is the formula we have. And this is what we have used here. So anyway, so this is done, for this chapter, we have done all these things. Okay, I hope you understood this properly. Okay, fine. So this chapter is over. We'll take a break now, and after the break, we'll start hydrogen. Okay, hydrogen and its compounds. Theoretical chapter. We'll do it quickly. Okay, you have to read NCERT throughout for this. Okay, so take a break now. We'll resume the class at 6:45. Okay, we'll start with hydrogen. Correct? Yes. Take a break. 6:45 will resume.